Hello. Okay, I'm going to do the last three derivative rules, and they're the hardest. So we got the product rule. We learned this in class, and the product rule is just to help us find derivatives when we have two things multiplied by each other. So let's just write out what the rule is. So let's say your function is f of x equals, well, let's make it h of x equals f of x times g of x. So if you can just picture that, you have two functions multiplied by each other. So if you want to find the derivative of that, the rule is you find the derivative of the first function, multiply it by the second function, then add it to the derivative of the second function times the first function. So that's the product rule. So let's see how it actually works. So if you had f of x equals let's say you had let's say your first function was 3x squared, and then your second function was x plus 1. So there's your function, 3x squared times x plus 1. So if we want to find the derivative of that function, f prime of x, first we find the derivative of the first function, which I'll highlight in yellow, and the second function is highlighted in blue. Okay, so our first function's derivative is 6x, if you use the power rule to figure that out. So we just did that. And then we have to multiply it by g of x, so just the straight second function, x plus 1. Then we put a plus sign. Then it says we just write the first function, which is 3x squared. Then we find the derivative of the second function. So the derivative of x plus 1 is just 1, because 1 doesn't have it, like the derivative of a constant is just 0, so the derivative of x is just 1. Okay, so that's our answer, and we don't want to leave it like this because it's not in standard form or factored form because of that plus sign. So either we want to expand it or common factor it or just do something to it. So if we just go ahead and expand it, because it's not that much expanding, I'm going to multiply my 6x through the brackets, so I get 6x squared plus 6x plus 3x squared. Then I can add my x squareds together, so I have 9x squared plus 6x. And I can leave it like that. That's in standard form. Or if I want to factor it, I could just factor out a 3x, and it would become 3x plus 2. So whichever. Both of these answers are fine. Standard and factored form. Totally good. But that's how the product rule works. And quotient rule is next. So quotient rule is, okay, let's say you have, wait, just write this down, quotient rule. Okay, so let's say you had two functions, but this time they're divided by each other, f of x over g of x. So the quotient rule helps us find the derivative of a fraction. So if we're trying to find the derivative, h prime of x, we just do the product rule in the numerator. So we find the derivative of the first times the second, plus the derivative of the second times the first. And this, we also have to divide the whole thing by g of x squared. So I'm not going to do an example of this one. It works similar to the product rule. Yeah, so you just follow that example. Another thing to note is that if you wanted to, you could switch it so that you only had to use product rule, because you could always turn a quotient into a product, because f of x divided by g of x is the same thing as saying f of x times g of x to the negative 1. So technically you could only use product rule if you wanted to, and you never have to use quotient rule. Totally up to you. Okay, the last and hardest rule is called the chain rule. And this is where we just combine all the stuff we learned into one giant equation. So let's say we had timeout. Okay, so writing the chain rule out, so let's say we had h of x is equal to f of g of x. So it's like you have a function within a function. So we call it like this would be the outer function, f of x, and g of x will be your inner function. So if you wanted to find the derivative of that, h prime of x, you would first find the derivative of the outer function, f prime of g of x, and then you would multiply it by the derivative of the inner function. So you're taking the derivatives of both functions. You just have to do the outer one first and leave the inner one the same, and then do the derivative of the inner function. Okay, so let me just do an example and then we're done. Okay, so let's say our function was, let's just do an easy one. So like 3x squared plus 5 to the power of 4. Okay, so we've got two functions. We've got the inner function, which is 3x squared plus 5, and the outer function, which is something to the power of 4. So if we're dealing with our outer function first, so let's find the derivative, h prime of x. So if we're dealing with our outer function first, you just kind of, anything could be in brackets. It could be like a pineapple to the power of 4. This doesn't really matter what's in the brackets. You just leave the brackets the same. So you take your exponent, put it out front. Whatever is in your brackets, you just write it. And then you're doing your like power rule. So the 4 goes in front, so you subtract 1 from your exponent. So that leaves you with cubed on top. So that's your derivative of your outer function. Step 1 done. Step 2, you have to multiply that by the derivative of the inner function. So the inner function is 3x squared plus 5. So the derivative of 3x squared plus 5 is 6x. And that's your final answer, except it looks kind of ugly because there's a whole bunch of terms, so you want to combine stuff. So you want to combine those single guys, so 4 and 6x, so that would be 24x. And then you can just leave that bracket as is, and now your function is in factored form, and it's totally fine. And that's the chain rule, but that's the easiest question of the chain rule. So the chain rule can be kind of crazy because let's do a crazy example. So h of x equals, say you had 2x to the power of 4 minus 3x, and all of that is to the power of 3, and then that's times x plus 1, I don't know, squared. So that's crazy. You have like a product rule and a chain rule within the product rule. So you have like a whole bunch of stuff going on at once. So if you're going to find the derivative of that, we want to follow the product rule format and then use the chain rule within the product rule. Okay, so pretend like this is your first function and this is your second function, and then within those functions you have more functions. So that's your first function, and this is your second function. So let's remember the product rule is find the derivative of the first function times the second function, then add it to the derivative of the second function times the first function. So that's the pattern we're following. So let's find the derivative of function number 1. So the derivative of function number 1 contains the chain rule. Okay, so to find the derivative of this, we do 3 times 2x to the power of 4 minus 3x squared. So we just found the derivative of the outer function times, we're still just finding the derivative of number 1. So we still have to times it by the inner function. So the derivative of the inner function is 8x cubed minus 3. So all we've completed right now is f prime of x. We've only done step 1 of the product rule. We've just found the derivative of this yellow highlighted mess. So it was hard because you had to use the chain rule to find the derivative of the first function. And you did. Done. So the next step, it says you just have to multiply it by g of x. All right, cool. So that's our second function. So you just multiply it by x plus 1 squared. Done. Now we're half done. Then we add it to f of x. So f of x is just your first function. So 2x4 minus 3x cubed. And then we multiply that by the derivative of your second function. Second function is x plus 1 squared. So again, we got to use the chain rule. So we bring the 2 down, write the junk in the brackets, subtract 1 from your exponent, so now it's to the power of 1. And according to the chain rule, the next step is to find the derivative of the inner function. So the derivative of x plus 1 is just 1. Okay, there, we're done. But it's super messy. So we have to just neaten it up a little bit. Oh no. Okay. So I wouldn't go ahead and expand all those brackets because that's going to take forever. So we're just going to neaten it up a little bit. Is there anything to neaten up? Not really. No, there's not. I'm just going to get rid of this 1 because when we multiply something by 1, it doesn't change it. So let's just leave that out. Okay, so what I'm going to do is common factor it just to make it look nicer because we don't want it in this form. We only want it in factored form or standard form. So we got to do that crazy complex factoring we learned in class. So what you want to do is look at this whole section and this whole section. What do you have in common? Okay, well the two things that I notice are this bracket's the same as this bracket and this bracket's the same as this bracket. So that's something they have in common. So we're going to factor that out. Anything that's in common we'll factor out. So 2x4 minus 3x is the common thing between them. This one has 2 of them because it's squared, and this one has 3 of them. So I'm going to factor out the least number, so that's 2. Then I'm going to look at my yellow one. That's common between the two terms. So I'm going to factor out an x plus 1. This set has 2 of them, and this set only has 1 of them. So I can only factor out the lowest amount, which is 1. Okay, so that's my common factor. So then I'm going to put another set of brackets. And now my job is to go through each section and see what I've got left. So if we're talking about this first section, you got to go through and say, all right, what didn't get covered in this? What am I missing? Well, I'm missing that solo 3. Write that down. I'm missing that 8x cubed minus 3 bracket. Got to include that. Oh, also, this x plus 1, you had 2 of them, but you only factored out 1 of them, so you got to put that in. Ooh, this is ugly. All right, so that's everything I'm missing from the first term. Oof. Okay, then we'll put the plus sign. Okay, now let's look at the second bunch of stuff and say, hey, what didn't we factor out? So the blue bracket here, we had 3 of them, but we only factored out 2. So we're going to have another 2x4 minus 3x. We also have this solo 2 that we need to put in. I think I'll stick it in front of my bracket there. And x plus 1 got factored out, so it's fine. So that's our answer, but again, we need to neaten it up a little bit because this second bracket's like a disaster. So 2x4 minus 3x squared, x plus 1. Okay, this doesn't really look fun, but we need to simplify this giant bracket. I think there's no nice way. You just got to go for it. I'm just going to multiply this 3 through my x plus 1 bracket to make it 3x plus 3. There we go. And then I'm going to FOIL out this bracket here. I'm going to do this because I don't want to rewrite this question like 15 times, so I'm just going to do it on the spot here in my head. So 24x to the 4 plus 24x cubed minus 9x minus 9. That's ugly. Okay, and then if I were to expand this bracket, I would get plus 4x to the 4 minus 6x. Okay, awesome. So now when I write my final answer, I just need to collect like terms. So 24x4 and 4x4 are like terms. So that makes 28x to the power of 4. So those are gone. Plus 24x cubed. And then the 9 and the 6 can go together. So that's negative 15x minus 9. Okay, awesome. So your final answer is this entire thing right here. That's the derivative of the thing we started with, which you probably forget now, but it's that guy right there. The derivative of that is this whole bunch of junk. Oh my goodness. I hope I didn't make a mistake. That's so big. So yeah, if you're watching this and I made a mistake, tell me in class and we'll fix it. But it's kind of crazy. Okay, awesome. Okay, that's it. That's pretty much as hard as it gets. Okay.